All right, so let's get back into it. So, this is actually a really interesting topic that we had brought up in class. I'm not going to get into the nitty gritty of it. I'm not going to really touch the derivatives regarding the function that you see here. Um, well, what I can say is that we do know that there's going to be some kind of a function. It's probably going to come down through here and go up and then go down and then go up again. That's going to essentially, what it's going to do is it's going to be a little bit different than that. But its roots are going to be everywhere where there's a maximum and a minimum point on this graph. And so, how do we label these? What exactly is a max and a min? And so that's what we'll discuss here. And also, you know, um, there's a bit of a situation here it's kind of an interesting thing that's presented to us. Neither a max nor a min, but it's also something a little more than just an inflection point, which is something that you can get from the second derivative. So what we have here at the top is a global, this is a global maximum, or absolute maximum. But it can also be defined as one of the local minimums, as one of the local maximums. This right here where the tangent equals 0, this is where we get our maxes and our min points. This right here is a local maximum. This, because as you can see, the function continues, both sides going downwards to infinity. Because of that, this can't be a global minimum or an absolute minimum. This instead then is just a local minimum. So what's this? This is really interesting. This is neither a maximum or a minimum point. This is an inflection point. This right here is an inflection point. However, this is also a very interesting scenario because this particular inflection point can also be termed, it's also known as a saddle point. Which I think has a lot to do with how it looks.